guys, we've talked about secants and we've talked about chords and arcs and all that good stuff. We're going to continue talking about arcs, but we're going to add in another vocab word, and that's a tangent. So, a tangent line to a circle is going to touch the circle in just one little spot. So, just like the circle is round, it's just going to it's a line segment that just barely kind of overlaps the circle in one specific spot. Probably a tangent line that you guys have seen is the top of the key and the 3-point line on just a regular basketball gym, not like college or NBA, where the 3-point line doesn't touch the top of the key, but just barely touches it, and then it continues on with that arc. So that's a point of tangency. So it barely touches that one little spot. So that's what a tangent line is. A tangent line is also going to create a 90-degree angle with the radius. And there's a couple of theorems with tangents, so we're going to look at those. So the first thing is that intersecting tangent segments, so two segments that are tangent to a circle, when they intersect, those two lengths outside the circle are going to be congruent or equal. So if we have our circle here, and then we'll have our tangent line. So a tangent line is just going to be a line segment that is going to barely touch the circle. Okay, that's a tangent line. And then we have another one. Okay, so kind of a little sketchy there because I didn't draw the first segment out far enough. So what we have is that these two segments right here and right here are going to be equal. All right. So let's say that it touches the circle in a point here and a point here. We'll call that point A and point B. And then they connect out here at point C. So the segment of AC is going to be equal to BC. All right. So they're going to be equal. So we'll probably have an expression there where we'll have to solve for x, or maybe we'll have a distance on one of them and then an expression on the other one, and we'll again solve for x. And then the second theorem is the measure of the angle formed by the intersection of two, The second theorem that we're going to look at is the measure of the angle formed by the intersection of two tangents outside the circle, so just like we had, is half the distance of the intercepted arcs. So here we go. Let's draw our circle and two tangent lines, okay? So also, this says half the distance. This is supposed to be difference. So it's the exact same as the secant lines, except with secant lines, obviously you have more, what's the word I'm looking for? I guess you really have two clear intercepted arcs. These are not as clear. So because the tangent lines just intersect at one spot, okay? So this angle right there, I'm going to call it theta, okay, is going to be equal to half the difference of this arc here, which is A, and then this arc from here to here, which is going to be B, or we might also find that as 360 minus A, because that might be what we're given. So just kind of keep that in mind, because remember, an entire circle is 360. So theta is going to be equal to half the difference. So B, the arc B, is obviously larger than arc A here. So I'm going to do B minus A just so I can keep a positive number there. All right, so now let's look at these as far as problems. On this one, we're going to find, for example 1, we're going to find the value of x. So what you'll notice is that I have two tangent lines. So here's the thing. We're splitting all these up into different lessons. But when you get a test or something like that, it's going to be all kind of mashed together. So you're going to have to be able to identify what even am I talking about? Are these secants, are these tangents, or whatever? So you just need to make sure that you're able to identify those. So here we're looking for the value of x. We have two tangent lines. They're going to make 90-degree angles with the radius there. So I know that this segment is equal to this segment. They're congruent. So therefore, 5x minus 18 is going to be equal to 3x plus 2. So I'm going to subtract 3x from each side, and then I get 2x minus 18 equals 2. Then I'll add 18 to both sides, and then I get 2x is equal to 20. And then lastly, divide by 2, and so x is equal to 10. All right, so if they wanted to know the segment length, then you would need to go back and plug it back in into either one. It's going to be the same. So that's for the congruent segments. Now let's look at finding an angle measure. So we're going to find the angle measure of EFD. Just following those along, I'm finding the angle measure of this. So remember that the angle measure of F is going to be half the difference of the intercepted arcs. So the intercepted arcs are going to be right here and right here. Now, the darker blue arc is going to end up being 360 minus 124. All right. So I'm gonna call this theta because I like naming it like that instead of having an angle measure. So theta is going to be equal to half of that difference there. So the dark blue arc ends up being 236 minus, I wrote 124. Okay, so then I'm going to go ahead and subtract those two. So I have half of 112, which ends up being 56 degrees. So that's going to be theta, or the measure of angle EFD. Okay, right there. All right, and then so that's it for the arc lengths or with the angle measure. Now we have a couple of things going on here. We're going to find the length of the arc PR, and then we're also going to find the measure of QR. So the first thing I need to note is that the measure of this angle right up here is going to be 31. All right. It wants us to find this length. Instead of using X, I'm going to use A actually because I use X in the other one, and I don't want you to get that confused. So that's going to be A. Now, remember to find the angle measure, which I have this time. I'm going to have to find the difference of the two arcs. Well, I just have one. Well, remember on the last problem, we just had 360 minus that arc that we were given. So same thing here, except we just have an expression. So the arc from P to R is going to be 360 minus A. So here we go. I know that theta, this is theta right here, 31, is equal to half the difference of the two arcs I have. So 360 minus A, and then minus A again. So this A comes from right here. So I try to put those in the same color so you can see them a little bit better. And so that's going to be equal to, let's see, I'm just going to go ahead and make this a little bit nicer and combine my like terms. So I have 360 minus 2A. Now, you can do one of two things here. You can either multiply by 2 to get rid of the half, but everything inside the parentheses is kind of nice, and I could probably take half of everything inside the parentheses, so I can distribute that half. Or multiply by 2 and get rid of it. It doesn't matter. It's going to all end up being the same. So then I'm going to take half of 360, that's 180, and then half of 2A is just A. So that ends up being nice and pretty. So then I'm going to subtract 180 from each side, and I'm going to get 149 negative is equal to negative A. And so then I'm going to divide by negative 1 because that's that number out front. So A is equal to 149. 149. So this is 149. And then the second part is asking for the measure of QR. So it's a measure of that segment there. So let's look here real quick. We're going to, so this is going to be the B part. I'm going to have to kind of come over here and write it out. So the measure of QR, so remember that these two segments are going to be congruent. So I have 4x plus 5 is equal to 0.5x plus 9. So I'm going to subtract 0.5x from each side. And that gives me 3.5x plus 5 is equal to 9. And then I'll subtract 5 from each side. And 3.5x is equal to 4 now. Then I'll divide by 3.5 on each side. And x is equal to 1.14. Now, it asked me for the value of x. It asked me for that length. So I need to go back and plug it in for x. So I have 4 times 1.14 plus 5, that's going to be 9.56. And that's roughly because I kind of did some rounding with the 1.14, but that's going to be the measure of QR, roughly rounding. All right, so this is tangents. Again, you want to make sure you know the difference between a chord, a tangent, and a secant. And it is your turn to practice with quizzes or your skill check.